So when we read a question and we know it's a hypothesis test, the first step is to set up the null and alternative hypotheses. So we have an example from a previous video, and there we are trying to either prove that the average weight of babies born to moms with gestational diabetes is either less than, greater than, or not equal to 3.4 kgs. Basically, if we have reason to believe that mu is always equal to 3.4 kilograms, mu is the population mean weight of babies is 3.4 kilograms, and the alternative hypothesis is what we are trying to prove. It depends on the question, but the three different possibilities are less than, greater than, and not equal to. So once we set up the null and alternative hypothesis, we know that this number here is the mu O. So the next step is we find x bar from the sample. So we find x bar from the sample of measurements. The x bar is then converted to its z-value on the sampling distribution using the formula z equals x bar minus mu O divided by sigma over radical n. Once this is done, we've converted the x bar into its standard normal form. So we've standardized x bar. So now we look at the standard normal distribution with 0 in the center. Now the 0 in the center really corresponds to a null hypothesis that tells us that mu is equal to 3.4 kilograms. Remember, that's not what we're trying to prove. We are trying to prove that either it's less than, greater than, or not equal to. So for the sake of argument, we say let's just assume that it is the mean, in which case that mean would be sitting in the center of the distribution. So when that is converted to its z-value, we get a 0. So now, if we are trying to, if we are successful in proving that mu is either less than or greater than or not equal to, so let's just look at the first case. Mu is less than 3.4 kilograms. So if in the first case, we'll get a z-value for x bar. Remember, x bar is converted to its z-value. We get a z-value to the left of 0. Since it's a left tail test, we find the area to the left of the given z-value. This is the z-value of x bar. And remember, that area is called the p-value. If it's a right tail test, then the area to the right is what gives us the p-value. So we find the area to the left from table B and then subtract that from 1 to get the area to the right. So each of these would be a p-value, and for not equal to, it depends. If the z is on the left of 0, which means if z is negative, we take the area to the left and multiply it by 2. If the z value falls to the right of 0 and it's positive, then we measure the area of the right tail. So it's the area to the right of that z value. So that's the second case. And then if it's a two-tailed test, we find the area, either the left area or the right area of the tail, depending on which one is appropriate. And then you multiply it by 2 to find the p-value of the z statistic when we have a not equal to in the alternative hypothesis. So once we have a z value, let's just say z equals negative 2.13. So when z equals negative 2.13, just draw the z distribution first. The 0 sits in the middle, -1, -2, -3. So clearly the z value has fallen to the left of 0. So we take the area to the left of that z value. So it's a good idea to draw or sketch the standard normal distribution, so it'll be clear to you which area you look at. So how do we find the area to the left of a z value? We go to table B, and the entries in the table are the areas to the left. So we don't really need to subtract from 1 in this case, because it's the area to the left that we need. And the area that I get from table B is, so I go to negative 2.1, and that's the row. And the column is headed by 3, so it is 0.0166. So that is the area to the left, 0.0166. So this is called the p-value. And clearly, if we look at a 5% significance level, which is 0.05, 0.0166 is way less than 0.05. So immediately we know that we can reject H naught. And what is H naught? H naught says mu is equal to 3.4 kilograms. So when we reject it, we are saying that's not true. And more specifically, if mu is less than 3.4 kilograms for HA, then definitely we have evidence to support our claim that mu is the average weight of babies is less than 3.4 kilograms. Now suppose Z is equal to 2.71. Then it's fallen to the right of 0. Let's just say that's 2.71. Let's assume that is 2.71. Now the tail would be to the right of 2.71. Tail is the end basically. So the end would be the shorter end, so that would be to the right of it. So let's look at 2.71. It'll be on the second page of the table because it's a positive z value. So we have 2.71, which is 0.9966. So the table entry is 0.9966. But the table entry always gives us the area to the left. Just remember this, always. The table that we have in our textbook shows us the area to the left. However, if you want to get the area to the right, then since the total area is 1, we subtract 0.9966 from 1. So that would be equal to 0.0034. The reason why we subtracted the table entry, which is the area to the left, from 1 is because we wanted the area to the right. Remember that the total area under the curve is always equal to 1. Now, if it's a two-tailed test, you basically find the area of any one of the two tails depending on which side of 0 our z value falls, and then multiply it with 2. Now this clearly, if we want to make a conclusion, is less than 0.05. So we can reject H naught. When we multiply by 2, 0.0034 is equal to 0.0068, which is still less than 0.05. So we reject H naught. H naught is something that we are going against. Remember that. We're trying to prove that mu is either greater than or less than or not equal to, and therefore it's completely against the null hypothesis, which is mu equal to 3.4.